Welcome back to another video tutorial on using Nina. In this 10th video we're going to look at some more advanced sequences and how to use some of the features that come in the plugins in order to make them even more intelligent. I've just loaded Nina and I'm going to load a profile for some equipment. And we're going to take a quick look at the plugin tab. The plugin tab has two available submenus. One is a list of the available plugins and whether there's updates available for them, which you can also hit this button at the bottom here. And the other one at the top is the installed plugins. And I've just installed a couple here. There's one which allows you to connect and disconnect from devices in software. Another one that allows you to do filter offset calculations. Another one that we'll be showing you later to do conditional imaging based on the moon illumination and angle. There's a couple of other interesting ones which I'm not using today that allows you to track non-sidereal objects, in other words orbitals like comets or asteroids. There's another one that gives you a number of additional commands that allows you to start and stop an imaging sequence based on the information about the target in relation to your local horizon. This one here is rather an interesting one that makes use of an obscure DOS command that allows you to copy files in the background to a remote disk drive. This one here, as it does, simply just shuts down the PC, which can be useful at the very end of a sequence. And this one here, and we'll come on to a little bit later on, allows you to run multiple camera rigs. So I have an observatory with a roll-off roof, and I've started to use two equivalent field of view camera systems on the single mount and run them in parallel, and this is the plugin that allows you to do that. What we're going to do first of all is take a look and refresh our memories about templates and populating them with targets. Let's start by looking at the Sequencer tab. And in the Sequencer tab on the right hand side we can drag instructions individually onto your main screen, and alternatively we can start to form those instructions into groups which we call templates, which we can then reuse for different imaging sessions. And that is what we're going to do here. So in one of the previous videos I showed you how to create a template, and what I'm going to do is show you a very simple sequence with a single camera and what we can do to enhance it. Let's just simply find Start Up Observatory, and then we're going to wait for a target, and then we're going to take some pictures, and then we're going to shut down the observatory. So I drag the start and the stop into the top and bottom areas, and then what I have is two groups of instructions, one which waits for the target to be available and another that takes the pictures, and then it shuts down. And at that collapse level it's quite easy to understand what's going on. So let's take a look in more detail at what's happening. If we expand the first tab, which is basically to start up the observatory, in which time the roof opens and the equipment starts to cool down to the ambient temperature, but it also needs to do it safely. So I think we've described this a little bit before, but what we can do is we can put in various instructions that pause and stop or repeat depending on conditions or the time. So we wait for sunset, and we also wait until safe, and then once those two conditions are met it'll go on to open the shutter of the dome, unpark the scope, find its home, because this is a paramount mount which needs to find home before it knows where anywhere is, and there's a small delay, and then it parks the scope and starts to cool the camera. So that first bit readies the mount and keeps the roof open. But, and the significant thing is that once it's done that, it comes out and moves into the second one. So this is the cooling period. So the camera's cooled, but the telescope optics are starting to cool, and it will keep on going around this loop until such times as we get to nautical dusk. So we can choose a number of different settings for what type of time frame we want to wait for. In this case it's just as it gets dark, but not dark enough to do the imaging. and it'll go through 2 loops. So if I collapse these down, there's a safe wait loop and then there's a close and unsafe loop. So while waiting for going dark enough to start doing things like autofocus and centering, it will sit in here whilst it's safe, so it's a loop while safe, and all it will do is just simply go around in a circle, not really doing a great deal. The reason that it does anything at all is because if it becomes unsafe, it hops out of this loop and goes into this instruction. And this instruction parks the scope if it already isn't, and closes the dome shutter or the roof, and it waits until safe. And it waits for 10 minutes after it's been safe, and as soon as it's done that, it goes back to the beginning again, and if it's still not yet at nautical dusk, it then opens the shutter and waits for a time span of 10 seconds. So these 2 conditions allow you to keep the roof open while it's safe and close it if it becomes unsafe. And unsafe is defined by excessive cloud or rain. So I'm going to collapse those down for a second. That's the cooling period, and once we get out of the cooling period, we've got to our nautical dusk. We then have a simple check to make sure that we're okay before going any further. And that's because we could have reached nautical dusk at the time when it was unsafe. So here it just waits until safe and then opens the roof or the shutter. So in most cases these will be hopped over very easily because the conditions were already safe. And then we go into the first of the 2 interesting subroutines or sequences that are stored individually as templates, and that is to wait for the target and then to acquire the target. So let's just collapse this one down and open up the next one. So this waits for the target, and this uses one of the first plugin commands, which is loop while next target is below horizon. So it simply goes around a very similar loop to the one that we had up here, which is cool observatory until dusk. So here it was just simply waiting for dusk to happen, and if I scroll down, what it's doing here is something very similar, which is just waiting for the next target to come up above the horizon. So this is going to loop while it's lower than the horizon, and the reason that we separate this is because if I collapse this for a second, I can have several targets. So I can, for instance, duplicate this and then duplicate this one, and if you look here, if I collapse this all up so you can see it, I'll now have wait for target, acquire the target, wait for the next target, acquire the target. So I can repeat these 2 templates time and time again, and each one is multi-purpose so that I don't need to customize it other than putting in the target information for it to work, and I can have multiple targets on one night. So I'm going to just briefly get rid of those by hitting the bin icon and go back to this one here. So it's going to loop whilst it's safe, and again there's this redundant open the dome shutter if it's already open. If it becomes unsafe, it closes the roof after parking the scope, and so on. And so at the end of this routine, we've reached a point where the target has hit our horizon. And that horizon can either be a custom horizon that you can load, or it can just be a simple altitude. If I open the acquisition section, the target that's stored in the template is blank, and we need to put one in there. And the exposure information, which is part of the plugin as well. So now that we've got to the point that our target should be over the horizon, we now have a simple acquisition target that loops until astronomical dawn. And again, that's just a standard one of the loop conditions that you can draw down upon. And there's a second one here, which is loop while altitude above horizon. And again, we can either use this particular command either a fixed altitude or above your horizon. And just so that we remind ourselves, the horizon is stored in the options box down here. So the custom horizon, there's a link to the path name for it. So I've got a horizon called shed.hrz, and that is a text file. And somebody asked me on YouTube what that is, so let's just have a quick look. So if I open that up with a text editor, like Notepad, it's a simple text file of the angle, that's the azimuth in 5-degree intervals here, and the altitude all in degrees. And it's a simple file that goes all the way through from 0 to 360. And that is my custom horizon. But it's stored with a .hrz ending so that it is mechanized. So back to our sequencer. The first thing we need to do is center our target and make sure that everything's good. So if I expand this out, I change to my luminance filter. There's a few annotations. Make sure it's safe. Open the roof. That's basically if it's closed at the moment, but it normally isn't, so these are normally hopped over very quickly. Unpark the scope. Slew to the target, which is populated from the target information. Do the autofocus. Now that it's focused, the slew and center should be more reliable, because it's possible that if you're considerably out of focus that the plate solving might not work. So this does the fine tuning to the centering, and it starts the guider guiding. All very straightforward. But again, wait until safe. So again, I'm being cautious and not opening the roof until I know the conditions are good. Let's collapse that down and look at the next part, which is the acquisition while safe. So for instance, again, we have a main loop condition, says loop while safe, and if it becomes unsafe, it comes out of this loop, which is formed of two main acquisition phases, narrowband and red, green, blue. And if it's not safe, it comes out of here and goes on to the hibernate command. And the hibernate command does what it says. It stops the guiding, parks the scope and closes the shutter, and it will just continually go around this whilst it's unsafe. And again, if the scope has already been parked and the shutter's already closed, trying to do it a second time doesn't matter, but we don't do it 10 times a second. We have a delay of a minute, so it just waits a minute before trying to repeat the instructions. And again, if they're already there, the instruction has no effect. And once it's become safe, this loop is exited and it goes back up again and carries on with the acquisition. And the first part of the acquisition opens the target and goes through the beginning. So it opens the shutter, unparks the scope, slews and centers and so on. So in effect what we have here is 3 parts of an acquisition system. I'm sorry about the screen flicking around, it's the way it scales it up and down. So this centers it or recenters it. This acquires while safe. If it becomes unsafe, it pops out into this one, and when it's safe again, it comes around to the beginning of here and opens the roof and recenters. So these 3 small subsequences manage the roof in changing conditions. So the one we really need to look at now is how we can do the best of our data acquisition. So I'm going to expand this one out and look at what I've done. I've got various triggers to do either a change in temperature, or the fact that I've reached the meridian and need to flip, or I've started to drift from the desired centering position. So for instance, I've got autofocus after temperature change. So every 1 degree change, it'll go off and do an autofocus at the end of an exposure. If my guiding for whatever reason stops, it'll try and restore it. It'll also try and do a meridian flip at the right possible time. And this one, after each exposure, it just checks to see whether the actual image has gone too far away from the desired center, and if it has, then it recenters the image and carries on. And there's also a second autofocus trigger, so sometimes the temperature may be stable outside, but your equipment may be warming up and cooling down still. So as a backstop, I do autofocus after 90 minutes, which means that if I do have bad focus, it'll only be 90 minutes worth. And then this last one, dither after a number of exposures. This one is something I picked up in the forum from another user, and is a nice trick to reduce the number of times you do dithers, but have no net effect on the actual quality of your data. And this is probably a good time to explore that in more depth. Up until recently, I've always acquired all my filter acquisitions at the same time, so I've done all the reds, all the greens, all the blues, and so on. But somebody suggested a different way of looking at it, in a way that reduces the number of dithers. And the benefit of this is it saves time, because when you dither your guider, it can take up to 30 seconds or so for the guider to become stable again before you can start the next exposure. And so this adds up over the night. So if I expand out my narrowband acquisition phase, so you have the dither after exposures, and it's going to dither after 6 exposures. So what I do is, in my narrowband acquisition loop, I have hydrogen alpha, sulfur and oxygen, and I take 2 exposures of each, and I go around in a circle. But what happens is, after the 6th exposure, in other words, once it's got through this lot, it will dither, and then it will go back to the beginning again. So what you're doing here is doing 2 exposures of hydrogen alpha without dither, and then sometime later on, after you've done sulfur and oxygen, you dither once for that whole group of 6 exposures. So it's exactly the same as doing all your hydrogen alphas together and dithering every other exposure, and so forth with the sulfur and oxygen. But you're saving a lot of dither events. And the other beautiful thing about this is, in a system with dual cameras, there is an alternative dither after exposures, which allows you to do a synchronized dither between 2 camera systems or more after so many exposures. And again, that improves the efficiency of using a clear night. Now, the other thing I wanted to show you was this rather clever little loop condition called moon angle, which comes in with the plugin called moon angle. And it adds 2 different commands. One is moon illumination and the other is moon angle. And they do slightly different things. They're conditional, that says, look, if you've got a bright moon, it's sometimes difficult to take exposures around a bright moon. And the closer you are to a bright moon, the harder it is. And so you might not want to do it. But you don't want to necessarily have to edit your sequences every night because the conditions have changed. But what you can do is make the sequence adapt itself. So clicking back on the sequence tab, this moon angle thing here, so it's basically saying here, when there's a full moon, if it's less than 50 degrees from a full moon, don't do this loop. It'll loop whilst it's greater, but it won't when it's less than 50 degrees. And this is a number you can change. And this little option here called Lorentzian, what this does is it alters the angle here depending on the moon illumination. So this is for a full moon, and you can see that because of my moon is not quite a full moon, the modified angle is being reduced to 40 degrees. You get the idea. If it's just a tiny little fillet of the moon, then you can get very close to it and do imaging without it being washed out. And I've done the same here for a second group of exposures, which are my wideband exposures for red, green and blue. But what I've done here is I've opened up the angle, so I'll only try and attempt the red, green, blue exposures if I'm 120 degrees from the moon. And this angle is calculated between the target and the moon at the time that you're taking the images, and it's computed in real time. And that's probably a good point to show you how you can populate a sequence with target information, which was another one of the YouTube questions. If we scroll back up to the target information, you'll see that there's nothing here. And there are multiple ways of bringing in target information. There is a list of targets on the side of here, some of which have been populated beforehand and others which I have done. And it can be a simple case of taking your target and dragging it onto here. And as soon as you do that, you can see where your custom horizon is, you see the moon phase and where the target is, and then so forth. And you can see a tiny little version of that little graph in each of these cases. So it's quite a nice way of selecting a target that looks promising for any particular imaging night. There are other ways of populating a target directly from the Framing tab. So for instance, if I click to the Framing tab, I can create a name like, say, M31, everyone's favourite, click on it, the coordinates are loaded, and I can do load image. Now when you load an image, the image comes from several sources. I'm using the offline sky map, and if you follow Nina's instructions and install it, this is the best way of having a simple map if you're not connected to the internet. Some of these other sky surveys and maps don't always work, so it's worth trying out different ones if one seems to not load within a couple of minutes. Let's try the ESO sky map, and let's just load an image and see what happens. Again, if you make the field of view very large or you choose the wrong map, it can wait quite a while. And if it comes back 0, we'll try something different. There we go. So there's M31, and you can see that it's put my camera system on there, which is worked out from the information associated with the equipment profile, and you can see where it is. Now there's a number of ways of taking this target information and putting it either and saving it as a target for later use, or actually updating a target in a sequence. So for instance, I might not want to have dead center. So for instance, I might want to rotate it a little bit, say that way around, and move it slightly. So when I do that, the coordinates up here and the angle are changed, and I can now add that to my sequence. And there's different ways of doing it. So I can add the target to a sequence, or I can click this arrow here, and this first one is whited out because of my choice of colours, which isn't great. So I can either add the target to the target list, which is the top one, or update an existing target in the sequencer. So if I do that one, and then update the one that I previously just populated with Caldwell 19, you'll see that now it's been set to M31, which is great. If I go back to the framing wizard and choose the first one, so add target to target list, click on that, basic sequence target, which is probably the best one to choose. It says target M31 has been created. Go into the sequencer tab, and then there's M31 up there. If you want to get rid of a target, you simply drag it to the bin and it removes it. I think also if you click on your documents folder where Nina's stored, you can also simply delete it from there as well. So now you have your target information. When you look down here, you can now see that your current target moon separation is now 40 degrees and the Lorentzian modified limit is 40.25 degrees. So if I went to try and image this right now, I would run into difficulty because my separation to the moon is less than the limit, and this imaging sequence would not run, it would simply skip over it. So there's a couple of tricks that we've been using. You can also use the smart exposures, and do multiple exposures with lots of gains and things, but doing it this way takes a bit longer to write. It gives you more control of exactly what you want to do. And the other thing you can also do, if you choose to, is change the number of iterations. So for instance, you could change this to say 2 iterations if you want to prioritize your narrowband over your red, green, blue in any imaging session. But typically the narrowband is going to run for more occurrences because of the moon angle than the red, green, blue. And that's the reason, because I'm using red, green, blue typically just for star colour. But if I was doing, say, a galaxy, wouldn't change the priority. And I might even just remove this by hitting delete here and just getting rid of it and just doing red, green, blue for a natural colour. And then lastly, if I go back to the last tab, which is the shutdown tab, I'm using another plugin called the Connect plugin, and I'm disconnecting the equipment, and I'm doing it little by little. So after closing the shutter and parking the scope and warming the camera, then I can disconnect. In this case I have a wait instruction because I'm synchronizing this with another camera, and then I'm using a Pegasus power switch, and I'm switching off the power so it can't accidentally start doing something. And once I've done that, I can then turn off the switch itself. So in effect, the computer is still running, but everything else has been shut down and switched off physically. If I want to physically cut the computer out as well, I can add another instruction, and if I go to Utility, Shut Down PC, and then the actual computer will completely shut down as well. So everything will be idle and it will be consuming very little electricity. That's what I wanted to show you with regard to using some of the plugins, and the next video is going to look at dual cameras, and that uses another plugin called synchronization. It's a little bit work in progress, but it's a very exciting way of taking images when you don't have many clear nights in any year, and you can literally double up what you manage to acquire each night. So talk to you soon.